So essentially, I'm going to be talking about the PerlayStation Games Console. And it's really not really the reason I created any of this. This application that you can see is actually using the API that I created for some other project. The presentation itself is using the API that I created. It runs on a console, and it's all in as pure Perl as you can get. So who am I? My name is Saif. I'm an orthopedic surgeon, so I'm not a professional programmer. I'm a Perl grant secretary. I do have a CPAN ID, and I've created other projects, GUIDeFATE and Graille, which is, I guess, the main focus of this talk. So I'm going to give you a little bit of background about what motivated me to do this, what I really do, and I have to, as I say, I'm not a professional, so I don't understand a lot of things about Perl and programming, but I have certain needs which need to be filled, and I sort of make Perl do what I can to make it work. And then from that initial motivation, there was a distraction, something that took me away from what I really wanted to do, and then produce something else. And if you go through what the capabilities of this project is and the future, and we'll conclude with a rough idea of what I think the value of this is. And it may be of no value to many people, but so my interest in my research is about robotics and tissue engineering. So I do some tissue engineering work, and one of the work that I do involves research into 3D printing living structures. So 3D printing requires a robotic device that allows extrusion of matrix or cells or both in various geographic positions on a structure. So that requires some kind of sense and control requirement. So you can sense things and detect them on oscilloscope, but you have very little programmatic control over the data that you get from there. And if you want to have control and feedback, you need to be able to visualize the data as well as process the data simultaneously. So that was a few years ago. I created something called the oscilloscope. Again, as I say, my Perl programming is very limited. I don't know how to program a GUI really, so I did everything on a terminal. So the objective was to acquire data on real time, add some interactivity, and get some analysis of the data at the same time as being able to visualize it. So this was the oscilloscope. So essentially, here it is, just showing some random data that I can stretch or compress. I can move up and down. It's all in ASCII terminal, and I can speed up the data sampling rate, or I can slow it down a bit, and I can affect one trace at a time, and it's a dual trace thing, so I can influence either trace that I want, like an oscilloscope, and it gives me some control, and I can auto scale it as well to make it fit the screen. So this is all in ASCII. It's fairly limited. I needed a bit more control, and certainly with ASCII level charting, you can't visualize fine enough resolution of small changes. It's okay for some things, but it's not really okay. For instance, take an ECG recording on ASCII. So I wanted a higher resolution. I also want other display forms. They don't need to be charted. They could be bar graphs or something that alerts me of this. And I want to be able to simulate, for instance, the position of the robot's arms, the extruder's arms. So basically, I'm trying to create a terminal graphical toolkit because I'm focusing on the terminal. And one way of doing it is to use sub-character plotting. So there are a couple of ways of doing that. And I guess one of the ways was described a few years ago in Python by a project called Drawille by ascimoo. And of course, shortly after that, someone called Holstrow produced term.drawille, and that is a sort of clone of Drawille. And essentially the way it works is Braille characters have 8 little dots arranged in rows of 2 columns of 4 rows. And those Braille characters can be ported onto any console that has can display UTF-8 character. So that didn't quite have all the features that I wanted. So I produced term Graille, which is graphics in Braille. But it does more than just Braille. It does do Braille and quarter block. So this presentation that you can see uses both Braille and quarter block. You can see the title fonts are in quarter block. They're made of, instead of being, they're the blocks of 4 blocks, which each character, which can be arranged, and the Braille, the main text is in Braille. So the Braille dots that you can see, the text that you can see is actually in Braille characters. The dots being selected, the correct character being chosen to produce a display you want to display. You can see the Braille characters have gaps in it. The quarter block hasn't got gaps in it. Fortunately, Braille characters in UTF-8, they are logically, although illogically aligned, they're logically, in binary logic, they are consistent. Whereas the quarter block binary position of the plots are not consistent. So I produced term Graille. Its objective is to produce heterogenic drawing on a console. You can have multiple canvases. You can have multiple simple drawing primitives. It allows scripting of the drawing parameters, and it's also extendable with other modules. So this is what term Graille does. These are things you can draw pictures. You can script lines. You can draw lines in a canvas that you can do. If you can draw lines, you can animate them as well. So you can do animations as well. And if you can animate them, you can also draw pictures you wanted. And my main focus was charting. So I wanted to be able to chart them, and you can see the actual granularity of that is much more detailed than the oscilloscope. So this led me to deviate from my original goal. My original goal was to try and get charts, but I found that I needed to make things and test things as well. So here I am trying to create a graphical toolkit to which I'm going to add features. So I need and it has to be interactive. So I need to be able to test all these components individually, make sure the display is consistent and robust and responsive and versatile. And the best way to do it, I think, is probably to make games. That's how we all started. We all started coding by making little great games. And the games have applied different kinds of, each genre of game that you apply applies a different stress to your graphical environment, and you have to develop ways of working around that stresses. You can try features, you can add frills, and you can do all of these things. So one of the things you might need is extensions to the graphical toolkit, and one of them might be interactivity. So your interactivity, for my purposes, I'm not able to analyze mouse captured data, but I can detect key presses from term read key, and I can have menus. These menus are not using cursors or anything else. It's all a separate module for term Graille, and I can adjust and interact with my application through modules like produce a menu, dialog boxes, screen updates from my projects. I also want to have different fonts, mainly to attract attention, mainly for features. And fortunately, what's happened is that ZX Spectrum, an old 8-bit computer, has a huge array of available fonts in public domain, and some guy called Damien Griffin produced all these different fonts, which I can take the binary patterns on and convert them into Braille or quarter block, and then blit them onto my canvas through a little bit of that's the whole objective of the term Graille project. So one of the handy things about this kind of application presentation is that I can go from an external application, go back to it without having to do anything, without having to stop the windows, because everything's happening in my terminal, because my applications are in the terminal as well as my presentation software is also running in the terminal. So if you can plot characters, you can blit images. And here is an ASCII representation of a famous Perl character. But if I use a bit of image magic and Graille, I can get a better resolution picture of that character. And there may be other characters you might recognize in Perl and Raccoon and other people that might exist in Perl. So, and if you can do pictures, I can blit multiple different kinds of pictures. Here is a little application that takes multiple PNG images, converts them using image magic, and then blits them onto our canvas as a little bit of an animation there. And if I can do animations, I can control that animation. So I can have sprites. Here is a character that's moving up and down, but you can do other things. You can, obviously, that character is animated. It detects this edge. It will detect collisions with other objects if you programmed it to do that. And this happens independent of other interactions. So it is the interactive module detects your key press once every 50 seconds. And you can use that same interval when it's detecting your key press to update your screen. And that's how this works. This works so that it doesn't actually have a multi-threaded application. It's all running on a single thread, effectively, but simulating multi-thread application. And games wouldn't be games without sound. So this allows me to a monophonic synthesizer, which it generates this generates sine wave samples, but you could use any kind of sample to do that and use a piano. And you can also, if you can take samples, you can take some other kinds of samples as well. So this uses the allophone set from an old 40-year-old chip called the SPO256 that used to be used in 8-bit computers to make speech. So I found somewhere on the internet the samples that are used. They're not all exactly reliable. They can't produce a lot of sounds, and you have to have a dictionary. So you have a dictionary over here that can allows you to do that. But this particular application allows me to view the sound allophones, because I can now look at each individual allophone and see the waveform of that allophone. And that might allow me to algorithmically derive the allophone rather than doing the data sample capture. So this is something that I'm going to look at some point. So those are things that this thing can do. And so now I've got sound, I've got animation, I've got sprites, I've got interactivity. I can see if I can make some games. One of the games that I can try is Space Invaders. Sorry, died there. So not that I'm particularly good at games, yeah. So a bit flickery. I'm not. I think because my debugging message is overwriting the actual thing. But each of those little blocks that you can see, they're actually 12 sprites that are destroyed by the bullets. So there's collisions detected by the thing. So my wall is segmentally broken down sequentially. It doesn't disappear instantly because it detects those individual sprites, detects the missile and gets destroyed by that missile. So yeah, you don't want to keep on saying playing games, but that's one application. Another application is Breakout that you might try. So again, I've managed to get the, so I can, each of those blocks that are not moving have different capabilities, different results, and each of them, and in the first time you hit the block, you get an announcement of what the block does. Oh dear, missed that one. Okay, but essentially, again, as I say, you can do a few things, and it records the lives that you've lost using UGF hearts and those sort of things. So essentially, let me quit this game. So essentially, these things, what they do for me is that every time I create a new game, and I try different modules, different kinds of games, is I'm going to try and add features which will actually be useful to my main purpose, to use this as an environment that can be used for serious applications. So one of the things about as you do this, you find that you have to make some useful-ish side applications. Here's a text editor. I can edit text on there. I've got my little menu, so if I can edit text, I can load text on there. So it's got dialog boxes and selectors as well, and I can edit text over there. And if I can edit text, I can also edit scripts. So I can edit, I can load a script in Logo. As I said, one of the things that Graille can do is it can run scripting of your lines in Logo. So here's a Logo script that I created, and if I can run the script, if I can somehow. So I've got a run application, run Logo applications. I can run a Logo script and draw a picture on that. So essentially, this is like a little mini text editor that I can do other things with, all running of the same API, not using any other external libraries apart from term read key and a bit of audio, whatever it is that you have. But essentially, let me get out of this one. And if I can do this, sorry, just quit this one. So because it's all running on the actual presentation applications running on the background, it automatically goes back to the shell. And I can also do little editing of sprites. So if I create a sprite, I can just create a sprite and save it and load it as I want. And then I can create, because I can load sprites, I can create animations from those sprites, and then I can play them in sequentially. And these are all done with using Braille characters, which are mapped onto a little XY representation of the screen somewhere, of the canvas somewhere. So M. So again, this menu is not 100% reliable, but it is it does what it needs to do, and I can do things like this. Let's come back over here. I can let me just see if I can. Maybe not really, but yes. Okay, so let's clear that one. So it's a hierarchical menu, so I can rotate this 180 degrees. I rotate that 180 degrees. Yeah, you get the picture anyway. So and I can say I can load and save, because I can generate a file selector from this as well. So this is it. It wasn't going to be a very big talk, but I'd appreciate some criticisms, suggestions, if you want to collaborate or something, and questions.
So this was originally started off doing this for a medical application, right?
Sorry?
You started off doing this for a medical application.
Yes.
Did you ever get back to medical application?
Oh, no, I'm still doing it. The application is the device I'm creating is a mixture, is an electronic device. So the device controls little servos and motors to position a little extruder on a surface. So that is still the project that's in progress. So yeah, and I can talk about that in detail if you want. But essentially, the objective, my objective was extruding living tissue is problematic because the living tissue don't like the environment they come into. They need to be carefully nurtured, have the right kind of humidity, right kind of temperature, right kind of nutrient supply, and something that takes a long time to create will mean the cells that you've laid down first will die. So what most people do is make a gel and then seed the gel later on with cells. What that means is your cells are distributed homogeneously over the whole structure. I want to position my cells in a specific geographic location inside environment. So my device, unlike devices that print using XYZ coordinates, is designed to print a structure inside a small cavity with a narrow neck. The environment in that cavity is well controlled. So, but the extruder goes in through a small point. But that's a different project altogether. So basically, what I want to do is I want to have a UI that will allow me to do this. So what I want to check the positions. So I want to be able to say, oh yes, I want this robot to move, this extruder to move, turn 30 degrees this way. So I want to be able to enter 30 degrees and it does something. And I need to be able to sense that it's done that thing. So basically your robot has to know where it is at any one time. Your extruder positioning has to know where it is. So it gets feedback to make sure that what you've set it to do is achieved. So that kind of feedback loop requires me to give it a command or give a program a command, and that program must be executed. And then I must verify that program is executed from the sensors data that I get. So that's essentially sort of a crudish result. But ultimately, this is a drawing application as well. You're creating lines to make a structure. So I need to be able to visualize or deliver to it a structure, a shape that I want to draw. So I need to be able to script that shape drawing movement and then or port it from another image. And I need to be able to do that sort of programmatically. So that's the reason. But as I say, there are lots and lots of more clever people who do these things for 3D printers. And most of it is open source, but also a lot of it is actually written in Perl. But I am not that skilled to be able to recognize that. So I'm like a lot of people, I make my own things. So it's because I can't, I don't have the depth of knowledge to do anything that clever. So no, thank you. But as I say, if you looked at the code of all the 3D printers, they are very sophisticated, and I'm learning. This teaches me while I'm writing games. I learn something, and teaches me more. Okay, thank you very much. Thank you.